Hello everyone, this is Ramachandran, math tutor from Online Math for All. In this video, we are going to see some tricky SAT math problems. Okay, let's go to the questions. Here we have the first question. The length x and the width y of a rectangle can be related by the following system of equations. If both the length and width are integers, what is the area of the rectangle? Okay, the question says x gives the length of the rectangle and y gives the width of the rectangle. So now to get the area of the rectangle, we need the values of x and y. I mean the length and width. Once we get the length and width, we can multiply them to get the area of the rectangle. Okay, now to solve for x and y in the system of given two equations, we can use Desmos. Okay, now let me give these two equations as input over here. That is 1 over 3 times x square times y equals to 400. Okay, now let me take the second equation. That is 1 over 4 times x square positive y square equals to 169. Okay, here I got the graphs of the given two equations. Now, to get the values of x and y in the given two equations, we have to consider the points of intersection of the two graphs. Okay, here we have a point of intersection. Here we have a point of intersection. Here we have 4 points of intersections. Okay, now which one has to be considered to get the values of x and y? The question says both x and y are integers. I mean the length and width are integers, and also the length and width cannot be negative. So now in these 4 points of intersection, we have to consider the point where both the x coordinate and y coordinate are integers, and also both of them must be positive. So there is only one point, that is 10, 12. Here the x coordinate is 10, y coordinate is 12. So both x and y, I mean the length and width are integers, and also they are positive values. Okay, our aim is to get the area of the rectangle. The formula to get the area of the rectangle is length times width. Length is 10, the width is 12. So 10 times 12 is 120. So therefore, area of the given rectangle is 120 square units. Here we have the next problem. Let's go to the question. If a negative 3 the whole square positive b negative 4 the whole square positive c positive 5 the whole square equals to 0, what is the value of a positive b positive c? Okay, now let's consider the equation we have over here. The first one is a square term, that is a negative 3 is squared. The second one is also the square, that is b negative 4 is squared. And the third one is the c positive 5 is squared. We know that the value of a square term can be 0 or positive. It can never be negative. Here the addition of 3 square terms is equal to 0. Since the addition of 3 square terms is equal to 0, so the value of each square term over here must be 0, so that the addition of the 3 square terms can be equal to 0. Okay, if the first one is equal to 0, then what must be the value of a? Then a must be 3. Then only 3 negative 3 will become 0. 0 squared is 0. So we get a equals to 3. If the second one is 0, what must be the value of b? Then b must be 4, so that 4 negative 4 will become 0. Okay, then here, if this one is equal to 0, what must be the value of c? The value of c must be negative 5. Here I got the values of a, b and c. My aim is to get the value of a positive, b positive, c. Okay, now let's get the value of a positive, b positive, c. Let's plug in the values for a, b and c. For a we have 3, and for b we have 4, and for c we have negative 5. Okay, 3 positive 4 is 7, 7 negative 5 is 2. Here I got the value of a positive, b positive, c, that is 2. Here we have the next problem. Okay, let's go to the question. 7th root of p to the 4th power equals to t to the power of 5 over 6. In the given equation, p is greater than 1, t is greater than 1. If t equals to p to the power of 2n negative 1, where n is a constant, what is the value of n? Okay, now what we can do is we can plug in this p to the power of 2n negative 1 for t over here in the given equation, because t equals to p to the power of 2n negative 1. Okay, now let me plug in. Then we get 7th root of p to the power of 4 equals to, for this t, we can plug in this one. Then we get p to the power of 2n negative 1. And we can take this exponent as it is. That is 5 over 6. Here we have radical on the left side of the equation. Whenever we have radical, it can be written as exponent. Okay, when I write a radical as an exponent, it has to be a fraction. The numerator has to be 1. The denominator of the exponent has to be the index of the radical. Here the index of the radical is 7. Okay, p to the 4th power. Now I am going to write this radical as an exponent. Then the exponent will be a fraction with numerator 1. And the denominator is the index of the radical, that is 7. Okay, here a power is raised to another power. Whenever a power is raised to another power, we can multiply the two exponents. Then we get 5 over 6 times 2n and negative 1. Okay, now we can do the same thing on the left side. That is, a power is raised to another power. We can multiply the two exponents. Then we get p to the power of, when I multiply 4 and 1/7, I am getting 4 over 7. equals to p to the power of 5 over 6 multiplied by 2n negative 1. Here two powers are equal with the same base, that is p. Whenever two powers are equal with the same base, what we can do is we can equate the exponents. Okay, when I equate the exponents, I am getting 4 over 7 equals to 5 over 6 times 2n negative 1. Let me multiply both sides of the equation by 6 over 5. Let me do it over here. So I want to get rid of this fraction. That's why I multiply both sides of the equation by 6 over 5. So this 6 will cancel out. This 5 will cancel out. Okay, here 6 times 4 is 24 and 5 times 7 is 35 equals to 2n negative 1. Okay, now to solve for n, we have to isolate n. Let me add 1 to both sides of the equation. When I do so, this negative 1 positive 1 will cancel out. I'm getting 24 over 35 positive 1 equals to 2n. Okay, here I'm adding a fraction and an integer. Whenever I want to do addition or subtraction between a fraction and an integer, I have to multiply the integer by the denominator of the fraction. Once I'm done with the multiplication, I can take this 35 as a common denominator. Okay, let me do it. 24 positive. 1 times 35 is 35. Now we can take 35 as a common denominator equals to 2n. Okay, let me continue over here. When I add 24 and 35, I am getting 59 over 35 equals to 2n. Okay, now to solve for n, we have to get rid of this 2. For that, we have to multiply both sides by 1 over 2. When I do so, this 2 will cancel out. 1 times 59 is 59. 2 times 35 is 70. On the right side, we have n. Here I got the value of n, that is 59 over 70. Okay, let's look at the next problem. If px positive 5 times qx positive 3 equals to 8x squared positive rx positive 15 for all values of x, and p positive q equals to 6, what are two possible values for r? Okay, now let's consider the given equation over here. In this equation, we have to find two possible values for r. Okay, so using Desmos to get the value of unknown constant in the equation, we have to take this equation as input in Desmos. When I do so, instead of x, I have to take x1, and instead of equal sign, I have to use the tilde sign. Okay, now let me take this equation as input in Desmos. That is p times x1 positive 5 times q times x1 positive 3. Then we have to take tilde sign. Then 8 x1 square positive r times x1 positive 15. Okay, I've taken the given equation as input. Now we have to consider this stuff, that is p positive q equals to 6. Actually, this is also an equation, but this equation contains two unknown constants p and q. When I give this equation as input in Desmos, I have to solve for one of the constants over here, either for p or for q. Okay, now let me solve for p in this equation. Then I'm getting p equals to 6 negative q. Now let's take this one as input in Desmos over here. Okay, let me type it. That is p equals to 6 negative q. And the equation we have in the problem contains multiple unknown constants like p, q, r. Since it contains a multiple unknown constant, we have to give multiple values as input for x, I mean for x1 in Desmos. Okay, now let me type x1 equals to give multiple values as input for x1. What we can do is we can take 1, then take 3 dots, then take 10, close the square bracket. So Desmos will automatically take input values for x1, that is 10 input values. Okay, here I got the value of r, that is r equals to 22. And I find this value 22 in answer choice C, and I don't find 22 in other answer choices. So the correct answer choice for this question must be answer choice C. 22 and 26 are the two possible values for r. Here we have the next problem. The graph of a circle intersects the x-axis and y-axis at 4 distinct points, one of which lies on the negative x-axis at k, 0. If k is a constant, what is its value? Okay, here we have 4 points on the circle, and one of the points, that is k, 0, contains an unknown constant k. Okay, now let's take these 3 points as input in Desmos. Okay, click on the plus sign, click on table. So the first point is 0, 4, and the second point is 2, 0, and the third point is 0, negative 4. And let's consider the equation of a circle in standard form, that is x negative h the whole square positive y negative k the whole square equals to r square. Okay, this is the equation for circle in standard form. It contains 3 unknown constants, h, k, and r. Okay, now to find the values of the unknown constants h, k, and r, I have to take this equation as input in Desmos. Okay, now whenever I want to find an unknown constant in the equation using Desmos, instead of x, I have to take x1, instead of y, I have to take y1, and for equal sign, I have to use a tilde sign. Okay, now let me take this equation as input, that is x1. Instead of x, I'm taking x1, negative h, the whole square, positive, and for y we have to take y1 negative k the whole square, then we have to take tilde sign, then r square. Usually we use this kind of format in Desmos, that is for x we take x1, for y we take y1, and for equal sign we take tilde sign. We do it to get the values of the unknown constants h, k, and r. Here I got the value of h, that is -3, and k is 0, and r is 5. Okay, now let's take this equation as input in Desmos with the values we have for h, k, and r over here. This time I have to take this x, this y, and equal sign as it is, because now my aim is not to get the values of the unknown constants and I have to get the graph of this equation. Okay, whenever I want to get a graph of a particular equation, I have to use x, y, and equal sign as it is. Okay, now let me take the equation as input in Desmos, that is x negative, the value of h is -3, negative times negative will become positive, that is x positive 3, the whole square positive, then we have y negative k, the value of k is 0, then y negative 0 is just y, then we have y square equals to, the value of r is 5, then we can take pi square. Okay, here I got the graph of the given equation, that is circle. Okay, now let's consider the points over here, here, here. Okay, already we have these points 0, 4, 2, 0, 0, -4 in the given figure. Okay, now let's consider this particular point that we have at the place of k, 0. So at the place of k, we have -8. So here I got the value of k, that is -8. We find -8 in answer choice C. The correct answer choice for this question is C. Hello, hope you have understood the tricky SAT math problems explained so far. And here you can see a particular web page of my website which has a lot of SAT math resources. Here you can find 33 links at the top. In each link you can get 10 hard SAT math problems with video solution for each problem. And apart from that, first 33 links, you can see multiple links. In each link, you can get 5 to 10 SAT math problems in all categories like geometry, trigonometry, algebra, everything. And given link for this web page in the description, and also a given link for the SAT math problem YouTube playlist of my channel. Thank you.